A warm welcome to another present here. I am going to explain our mini project on circuit analysis. Find the Y parameters of two-port network by using LTSpace software. Done by myself, Monisha S. of register number 57. Team members are Lazi Lerishamari, Bhatmareka, Lingeshwari. Subject faculty Mrs. Manju Ma'am, Assistant Professor of ECE Department. Table of contents: objective, theory, procedure, output of virtual lab, output by simulation method, theoretical verification, and conclusion. Theory: a general network having two pairs of terminals, one labeled as input terminals and other labeled as output terminals, is called two-port network. The port designated 1 to 1' is assumed to be connected to the driving force and hence called as input port. Port 2 to 2' is connected as output port. In two-port network, four variables: input voltage V1, input current I1, output voltage V2 and output current I2 are identical. Only two of the four variables are independent and specifications of any two of them determines the remaining two. I1 is equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. Or in the matrix form as I1 by I2 is equal to Y11 Y12 Y21 Y22 of V1 V2. The Y terms are known as the admittance parameters or simply Y parameters and have unit of Siemens. The value of the parameters can be determined by setting V1 is equal to 0, that is input port short circuited, or V2 is equal to 0, output port short circuited. Thus, Y11 is equal to I1 by V1, Y12 is equal to I1 by V2, Y21 is equal to I2 by V1 and Y22 is equal to I2 by V2. Since the Y parameters are obtained by short circuiting the input or output port, they are also called the short circuit admittance parameters. Let us consider the circuit diagram. When the input parameters are short circuited, output we get on by using the LTSpace simulation, we get the values of V1 as 1.33 volt and I1 as 1 ampere and I2 as minus 0.666 ampere. On finding Y11 is equal to I1 by V1, on dividing this we get Y11 as 0.75 Siemens and Y21 as I2 by V1, that is minus 0.5 Siemens. Now the output port is short circuited. On getting the output, we get I2 value as 1 and the V2 values as 1.6 and I1 value as minus 0.8. The Y22 is equal to I2 by V2, that is 0.625 Siemens. On finding Y12, I1 by V2, that is minus 0.5 Siemens. On theoretical verifications, we get the parameters values as to find Y1 and Y21, short circuit the output port and connect a current source to the input port. Since the 8 ohm resistor is short circuited, the 2 ohm resistor is in parallel with the 4 ohm resistor. Hence, V1 is equal to 4 by 3 I1. I11 is equal to 0.75 S. By current division rule, Y21 is equal to minus 0.5 S. To get Y12 and Y22, short circuit the input port and connect a current source I2 to the output port. The 4 ohm resistor is short circuited so that the 2 ohm and 8 ohm resistors are in parallel. We get the output value as Y22 is 0.625 Siemens and Y12 as minus 0.5 Siemens. The theoretical verification is the same as the simulation output. Two-port network using virtual lab of IIT Bombay network theory. Applications of two-port networks. Two-port networks are used in mathematical circuit analysis technique to isolate portions of large circuits. They are used in electronics to model transistors and to facilitate cascaded device design. It allows similar currents or devices to be compared easily. Thank you so much.